Welcome to the Backyard Professor Responds videos. Going to do another deep dive. Today's t-shirt is Marvel Comics. I like the Hulk, Iron Man, the typical gang of heroes. Woohoo! So let's take another look. I produced a video just a couple days ago on the scientific context of Nassim Haramein and his protons are black holes and the total entanglement of the universe, and it is accessible to us, all of this vast information and energy, etc. I used the positive approach to inspire us, to try to get us to think in new ways. And I believe it's only fair, in order to be critical, in order to round out our study of this, to use our critical thinking, that we explore the scientific aspects of Haramein's claims even more closely, because there are issues. It's not that we disagree with Haramein. He is very inspiring, without question. But the question really is his scientific paradigm the replacement? Have we found the new gut, the grand unified theory? Does quantum physics and relativity now fit together in a reality that gives us access to the total amount of universal information right here, right now, in our life right now? Those are some of the claims. And I gave it a positive spin, and now I'm going to explore it more critically. I've already said that. So let's get going. This, once again, too, I have discovered that utilizing Chat GPT. Now, I've got the 4.0 version. I'm aware that the 5.0 is supposed to come out probably July, some say December, etc. I'm well aware of that, and I'm looking forward to getting that as a tool to help us inquire into multiple claims, including our own UFOs, which I am going to begin doing. The reason I'm picking on the subject of Nassim Haramein is because he claims he has overturned physics. That's a huge claim. That's an extraordinary claim. It's got to have some pretty significant evidence. He does it rigorously with mathematics. That's the impression we receive. He does it rigorously with an analysis of particle physics, quantum physics, relativity, and consciousness studies. And I have seen in other videos where he has claimed that the consciousness aspects of our consciousness can tap into that universal material, and we can improve our lives that way. Very inspiring, very exciting, somewhat encouraging. But the question is it valid at this point? And that's what I want to explore, because it appears to me like it's coming up in a negative sense. I'm going to get into the details, but I'm going to have chat help me through some of the details and the nuances of the philosophy, of the history, of the logic, of the presentation, and of the evidence from the quantum realm, because everybody likes to go to the quantum physics without question. So do I. But keeping it real is more important than just accepting everything we're told. If you have logical and reasoning fallacies, you can get into trouble. And Haramein has those. Let's take a look. Here's what I did with Chat GPT. I said, okay, what kind of math? looking up here. This is my question. What kind of math is needed to determine the ratio of a proton mass to its radius? Because it's the ratio of a proton mass to the radius that Haramein claims he found protons are black holes. That's in his documentary, The Black Hole, spelled WHOLE. So are there equations you can show me? Can you find the math articles of Nassim Haramein online and use his equations and show me what they mean and how they work? So here's the idea. To calculate the ratio of a proton's mass to its radius, you tap into a mix. Now, there's a mix of classical gravity, Schwarzschild black hole equations, Planck scale quantum relations. This takes a lot of work. So we're going to look at this. The Schwarzschild radius and mass radius relation. The Schwarzschild radius formula from general relativity is right here. We can see this. This is well-established mathematics. There's no question about it. For a mass, capital M, this one right here, it's Schwarzschild radius, RS. Whatever mass you have, you calculate with the Schwarzschild radius is the size of a black hole event horizon if the mass is dense enough. And the mass does have to be dense enough. So Haramein's key step in his paper, The Schwarzschild Proton, is, here's what he did, setting the proton's physical radius equal to this Schwarzschild radius. When you do this, you must, there's the equation right there. You have to solve for M because that's what we're looking for, the mass. Solving for M, doing some manipulations. This is now the physics formula that we're going to use. The RP, this part right here, the proton radius, is 1.32 times 10 to the negative 13 centimeters. The G right here, which we are going to multiply by 2 also. Come on. Anyway, the G is 6.67 times 10 to the negative 8 centimeters cubed. And C, of course, the C squared, is the speed of light, 30 times 10 to the 10 centimeters per second. When we put all these into the equation, here's the mass of the proton that Haramein gets, 8.85 times 10 to the 14th grams. That's a positive exponent, 10 to the 14th. This is drastically larger than the actual proton mass that has been tested thousands of times with multiple different kinds of tests. So here is the proton mass, 1.67 times 10 to the negative 24th. Now, there's something called vacuum energy connection. Haramein compares this calculated Schwarzschild mass to vacuum energy inside the proton. How he does this is he uses Planck scale density arguments, concluding only 10 to the negative 39th of that is needed for a proton to have its Schwarzschild radius. So beyond mass, we have the magnetic moment, orbital motion, force balance. He applies semi-classical approximations, orbital velocity. What he does is he calculates 2 Schwarzschild protons, each with the mass he found, 8.85 times 10 to the 14th G, into orbiting each other at the diameter. And then he gives the gravitational yield. Here's the formula that he uses. This is the rotation period, I should say. 5.5 times 10 to the negative 23rd seconds. In other words, they're going fast. Here's the magnetic moment. It treats a charge spinning at C around radius. The magnetic moment is how you find this, it yields between 2 to 3 times the observed proton magnetic moment. So his magnetic moment is 2 to 3 times bigger. So the holographic mass, what he does next is he relates mass and radius through Planck units. Planck units are the smallest possible units we can use to understand our physical world. He proposed the holographic mass concept. You count the Planck spherical units within a proton volume on its surface and on its surface. You define this ratio, the number of Planck spherical units within the proton, and then the number of Planck spherical units, he calls them Planck spherical units, on the surface of the proton. You define a ratio phi, the surface PSUs, divided by the volume, and you relate proton mass to Planck mass. Variants extend to electron through time scale, similar scaling arguments using the Bohr radius. So you can also find the proton radius via the fine structure constant. And what this does is it matches with high precision proton radius puzzle experiment values of 0.841 fermions. So the match is there. So what about it? Let's look at the critiques now. Many physicists are arguing that Haramein's derivations use circular reasoning. Now, this is not good. We will explore more of circular reasoning because part of the value of studies like this is we get to learn the logical as well as the illogical ways to present arguments. His circular reasoning, he set the proton radius to equal the Schwarzschild radius, then he declares it a black hole. The argument is he isn't producing anything new. It's all smoke and mirrors. He's simply defining general geometric ratios and circular rambling. Now, what we need to recognize is the proton radius puzzle is an experimental issue. So with our modern measurements and theory, and in this theory, we include many different types of scientific analysis that has been done over and over and over and over and over and over and over tens of thousands of times in the Big Hadron Colliders. There's numerous ways we can test this, including the QED form factor fits. It firmly supports 0.84 FM. But Haramein's black hole model remains highly controversial. So he is using the correct parameter. However, it's his circular reasoning that gets him into trouble. So let's take a look at the summary table real quick. The ratio of mass proton to mass radius. This is the math involved. Haramein's claim is the proton behaves like a mini black hole. The mainstream view is that the proton radius is r to the 8 is not accepted. The magnetic moment, the spinning charge is how we look at this. His is close to the value, and it's a simplified toy model according to the mainstream view. He claims it's close to the actual value. The holographic mass, the Planck spinning units, the surface to volume ratio, the fine structure constant, etc. There's numerous ways to tackle this mathematically when we're discussing the holographic mass. Haramein claims that emerges proton-electron mass from geometry. This is his stance on this. And his geometry in his documentary, Black Hole, is really fascinating. It really is. However, this is what is criticized as circular by the mainstream scientists. We'll explore this in depth. The proton radius, We use QED and the Lamb shift for proton radius. 0.84 femtometers matches the experiments, and here he does receive strong mainstream support. So to compute the mass radius ratio using the gravitational, you need R8. You need this formula. In this formula, Haramein adds Planck scale vacuum arguments and geometric scaling. This is his holographic Planck spinning units model that he uses. He produces numerically intriguing values, but critics argue the method is logically circular. Here's what we rely on in mainstream physics: quantum electrodynamics. We rely on spectroscopy. We rely on spectroscopy. We rely on scattering experiments like we have at CERN. We don't rely on gravity black hole analogies to determine proton radius. So here's my question. Are his arguments actually circular? That appears to me to be the issue. So the mainstream science claims it's circular. Okay, well, my question is, are they actually circular? That's what I want to know. And the issue is, yes, they are. And this is a fun little cartoon that describes what circular reasoning is between a parent and a child. And I think we've all done this. It's time for you to go to bed. The child asks, why? Because it's your bedtime. Yeah, shut up and go to sleep, kid, right? Now, this is a really important point because we can see the fallacy when we see it in that response, but it's tougher to see it in Haramein's model as he is exploring the proton radius, giving the proton a black hole status. And the reason this is such a critical issue is because if all protons are black holes and they are all entangled, then they all have access to the vacuum and the vacuum energy. You don't have to use any quantum physics mathematics. You can use Einstein's relativity right down to the quantum size, and therefore we have access to all of the information in the vacuum energy. And this is one of the speculations of how the UFOs also travel through interstellar space, is through this kind of spectacular physics, through this advanced knowledge of tapping in to the vacuum energy on the quantum scale, because it's literally, in the universe, it's literally infinite. So this is a tangential, somewhat, analysis of a very interesting physics claim to the UFOs, but the speculations tie in. And so we want to see, based on this new model of physics, if this can be applied to the UFOs, because we really don't know a lot about the UFOs and their propulsion systems, right? And we don't. So this is critical. Besides that, it's fascinating and fun because I love to learn. The core criticism against his model is his main arguments are circular, and especially in the way he derives the proton mass. So what is he doing? By assuming it has the radius and behavior of a black hole in advance, and then using that assumption to prove it's a black hole. Let's break this down carefully and fairly. What is circular reasoning? That is the question without question. And I'll go ahead and throw this up there. Here is what Haramein's doing. The proton is a black hole because it has a Schwarzschild radius. Therefore, we know it has a Schwarzschild radius because it's a black hole. That is Haramein's circular reasoning, according to his critics. Let's explore this further. An argument is circular if it assumes the very thing that it's trying to prove. And that's what we just saw. It happens when the conclusion is embedded in the premises. This is not a demonstration. It's a loop. So his key argument simplified. In the Schwarzschild proton, Haramein argues the proton radius is 1.32 femtometers, an empirical average. The Schwarzschild radius for a mass of M is found in this, and what he does in this particular formula is he sets the proton's physical radius equal to the Schwarzschild radius first. Proton radius is the Schwarzschild radius. And then he solves for mass. So he's using pretty nice, sophisticated physics formulas. And that's how he arrives at his 8.85 times 10 to the 14th gram. The amazing thing is that this is 10 to the 38 times the actual proton mass. The actual proton mass is 1.67 times 10 to the negative 24th grams, to the negative 24th grams. He is saying the radius is to 8.85 times 10 to the 14th, a positive number. And that's what makes this 10 to the 38 times larger than the actual proton mass. In other words, something is really off, and he treats it as the gravitationally confined vacuum energy mass of the proton. And this is really important. This is, in his view, the gravitationally confined vacuum energy mass of the proton, and it's absolutely gigantic in each proton. That energy, that vacuum energy, 8.85 times 10 to the 14th grams, is gigantic. And all of this energy and information is available to everybody because of entanglement on the quantum scale. That's why his claim is so controversial. And then he uses it to say, see, the proton is a black hole. So why this is circular? He first sets the proton radius to the Schwarzschild radius before doing any physical derivation. And then this assumed identity is what is used to calculate the mass that proves it's a black hole. He is not deducing from first principles. This is important. He's using a known value, the proton radius, assigning it the role of a Schwarzschild radius, and using that to deduce a mass that proves the original assumption. So if you want to prove a proton is a black hole, what you need to do is start from known mass and test whether the gravitational radius of that mass is equal to or smaller than its physical radius. That's what he didn't do. And so this is the mathematics that you would use to do that. And you can see when you do that, compare this with the proton radius. That's 37 orders of magnitude smaller than the actual proton radius. So by general relativity, a proton is not a black hole. And this is why, and why does this convince them? So Haramein's numbers, like the orbital speed approaching c or the calculated magnetic moment, these seem to line up with real physical values, sure. But this is a known feature of numerology based or retrofitted models, on retrofitted models. If you're allowed to start with your conclusion, in other words, using the Schwarzschild radius as the basis, you can force equations to look neat. It's like saying this, and I thought this was another really good analogy. Assume I'm 6 feet tall because I weigh 180 pounds. Now plug that into the body mass index formula and look, it proves I must be 6 feet tall. But wait, you assumed that height in the first place. See, assume I'm 6 feet tall and I weigh 180. So it's not that big. That's what circular reasoning is. So it's assumed from the start, the Schwarzschild radius. Yes, it's derived from the assumption. And the new mass to declare the proton as a black hole is it restates the original assumption. And he claims to match with the magnetic moment and is possibly interesting, but it's not a direct derivation, and therefore it can't be claimed to be a match. So what would make it non-circular? Start from known mass of a proton. And from that known mass, then you plug in, you use this equation and plug in the numbers to calculate the Schwarzschild radius. You don't just assume it's a Schwarzschild radius. Then compare that to the known proton radius. That's how you get rid of that. So, and this is obvious that the proton is not dense enough to be a mini black hole. It's only 10 to the negative 15th. So, and actually to show otherwise, you would need a new physical mechanism, not just symbolic substitutions, right? So here's my next question to it. I thought that was pretty well done. It makes it very clear. Is Haramein actually saying the proton is a black hole, or is he saying it is similar with black hole properties? Not quite sure how to word that. I'm attempting to defend Haramein to make sure that we're not misreading what he is saying. Sometimes we get stuck with the types of words people use or we misunderstand them. So I wanted to make this crystal clear. And it says, excellent question. And you're right to catch that nuance. The wording really does matter. And Haramein walks a fine line. So let's break this down. What does Haramein actually claim? So here we go. In his paper, The Schwarzschild Proton, 2009, Haramein does suggest that the proton can be modeled as a black hole. Okay, so we've got that. But he also implies more than just an analogy. And here's some key quotes. We are proposing, see, we're just trying to be careful. We're just trying to analyze the meaning of what Haramein is saying in his new physics model that is supposed to overthrow the entire physics community. And so we want to be careful with this. We want to make sure we understand what this entails and what is being said. And we also want to understand what kind of evidence is being used. And we are proposing that the proton may be, in fact, a Schwarzschild entity or a mini black hole. He also says, if the proton is considered a black hole, its mass would be 10 to the 15th gram. Remarkably, this coincides with the mass required to account for the strong force that confines nucleons. Now, that's interesting. So what is happening here is he's saying it is a black hole? Yes, he is. In his papers and presentations, Haramein asserts that, number one, the proton has the density and gravitational behavior of a black hole. Number two, its strong nuclear force is equivalent to the gravitational attraction at the Schwarzschild limit. And number 3, this implies black hole equations apply to the proton itself, not just metaphorically. So while he sometimes couches this in terms like modeled as, or it may be considered, he repeatedly draws physical conclusions from the model. And that's stronger than analogy. It's a claim of identity or equivalence. But is he just using black holes as a metaphor or a heuristic? At times, Haramein seems to back off and suggests he's making an analogy. For instance, he says, if gravitational forces are truly so strong at this scale, at the scale of the proton, then it follows that the proton behaves similar to a black hole, at least in some respects. Well, that sounds more like a theoretical analogy, but then he goes on to apply the full Schwarzschild formula to derive mass, and he uses black hole orbital mechanics to derive magnetic moment, and he claims this resolves the strong force problem. So, despite occasional suffering, he doubles down mathematically and physically on the proton being functionally or literally a black hole, at least one confined by vacuum energy or Planck scale geometry. So his statement is the proton literally a black hole. He says, yes, it may be a Schwarzschild entity. Is it exactly like an astrophysical black hole? No, it doesn't collapse or evaporate, but he claims it shares core gravitational properties. Is he making an analogy only? No, he uses full black hole equations and claims physical implications. And is it metaphorical in parts? Occasionally, yes, but his conclusions are literal and physical. So here is a clear side-by-side comparison of a Haramein-style Schwarzschild proton and a real astrophysical black hole across key physical traits. And this is the kind of comparison. See, what makes this so important, what makes this so much fun is this is exactly the kind of a comparison that we need to engage in. Here is a claim. Here is the stated mathematical ideas. Here is the stated physical evidences. This claim refutes and argues against another claim. So here's the other claim's physical evidences. Here's the mathematics that this other claim uses. Let's compare the two and see which one could perhaps come out to be more valid. I mean, this is the essence of solid reasoning. This method is the essence of critical thinking, and this is what we can't turn off and be safe in our world. And so rather than being told what to think, we want to analyze the evidence. We want to analyze the mathematics and the physics and the chemistry and whatever have you, the astronomy and the cosmology. And we want to come to a more complete understanding with all of the full weaknesses and strengths of every model that is being compared. And that way, we arrive at a probability toward the truth that is going to be more realistic. And that's what I'm doing here. The AI, the Chat GPT 4.0, the way we can use this to help us do this with various claims is absolutely superb, in my opinion. I love doing this type of a study. One, we want rigor, but two, we want fairness. And you'll notice as we go on, it does give Haramein some fairness. It's totally non-biased so far as I can. And I have tried literally to bend over backwards in order to control my bias and, in fact, try to defend Haramein and try to get ChatGPT to at least acknowledge, is there a mistake in understanding what Haramein says? That's what I just went through. But is this a valid mathematical and physics approach, etc.? I'm trying to defend Haramein, and in the process, what this does is it uncovers layers. Not that Haramein is being dishonest or cheating or being a brat. No, of course not. He's trying to figure out truth and reality too. So we are fellow travelers in this journey, but that doesn't mean all paths are the best paths to go, and we want to find out which ones are. That's what makes this so invaluable. So anyway, wow, boy, that's a long obfuscation of valid information. Let's keep going. This is so this is how you do it, side-by-side comparison. We're going to compare Haramein and an actual astrophysical black hole. And we're going to do so across key physical traits. Now, black holes were discovered approximately, we can say the 1980s and be safe, early 1980s. Okay, so as Einstein's relativity from the 1920s became, and then the eclipse that verified that the light can bend in space around a heavy object, and that really lit the world on fire with excitement. And so for the next several decades, relativity was explored and analyzed. And you've got those, I believe there's 10 general field equations of general relativity that was being completely explored through the physics and the math for, like 50, 60 years. 1980s comes around, and all of a sudden someone realizes, oh my gosh, if we actually solve these general field equations, we find black holes. Oh, what the hell is that? A black hole? I mean, that is as exotic as anything you could imagine in science fiction. So this got us all excited again about black holes. And of course, this is the rise of Stephen Hawking, who was perhaps one of the most world famous physicists who dealt with black holes and time, etc., and cosmology. And then Leonard Susskind and Gerard de Hooft. I mean, all of these physicists came in. Now we have Brian Greene, although Brian Greene has gone more on the string stuff. Of course, and Lenny Susskind does too. But anyway, so this black hole stuff has been being seriously looked at from 1980 on. Well, that's 1980, 1990, 2000, 2010. We're talking 45 years. And we're talking hundreds of thousands of physicists and mathematicians exploring absolutely every concept, every idea of black holes. They smash two black holes together and then they re-separate them mathematically, of course, and they're finding wormholes between the black holes. What's in those wormholes? What's their function? I mean, there's some fantastically astonishing mathematical, and they're attempting to find physical ways to explore and test what happens in our cosmos. So this knowledge is not just, they just thought this up yesterday. No. Yes, we have a boatload of information left to figure out black holes. We really don't know, though. We don't hardly know anything. But what we do know is pretty rigorous with the math. And in relation to as many other physical parameters that we can get to in our cosmos to make sure our understanding of the black hole is rounded out, it's pretty rigorous and vigorous. So they're not just making this up on the fly in order to try to show that Haramein's views are wrong. No. We've got enough that we have a baseline that we can test against. And if you're going to make a claim that says the baseline cosmology in physics is wrong, then you have to have some pretty good, powerful rigor to your claim, right? And so that's what ChatGPT helps me see if Harmon does have that rigor or not. And that's invaluable as far as I'm concerned. So let's keep going. So the mass, Harmon's mass is really huge. It's about 1 million tons. Now understand this. It's about 1 million tons in a proton is what he's claiming. And the typical, or no, I mean, in the black hole, compared to a typical black hole, is 10 to the 33rd grams. That's a stellar mass black hole, not a proton. So, I mean, it's half of a stellar mass black hole, the proton, is what we would have to conclude from Harmon's calculation. And that's hard. That's hard to believe. The radius, 1.32 times 10 to the negative 13th centimeters. This is the proton radius. And the radius in a typical black hole is about 3 kilometers per solar mass, approximately 30 kilometers for a 10-mile black hole. And the Schwarzschild radius is set equal to proton radius. This is what his assumption is. And we can compute the mass through this formula of any body, which is kind of cool. The escape velocity, V equals C by construction. It's light. V equals C at the event horizon. The confining force, now this is where he models it as gravitational, not the strong force. And he wants to, what this does, he claims, is see, we're using Einstein's theories of gravity, and so and we're at the quantum level, we're at the proton subatomic particle level, and so we're unifying the quantum physics with the relativity. That's why his claim is so important to look into. But the actual black hole has true gravitational confinement. The Hawking radiation is not even addressed. Perhaps the model likely too small. A real black hole emits Hawking radiation, and this is theory, right? Because we don't know what's really going on. We're learning a lot, but the density is enormous, absolutely staggering, 10 to the 93rd gram per centimeter cubed, whereas in a black hole it's much lower. It's about 10 to the 15th, 10 to the 17th gram per centimeter cubed, which is still enormously dense. Don't make the mistake of thinking this is light as a feather. It's not, but 10 to 93 is so absolutely insanely so much more dense that it's ridiculous. That it's like, you know, if everything's entangled with that kind of a density, that's why he says it's infinite energy, infinite knowledge, and he claims we can tap into it. The temperature is not defined in a black hole. It's very cold. 10 to the negative 8 Kelvin. That's really interesting. That's the Hawking temperature, a cold black hole. The evaporation is not even proposed by Harmon, but black holes slowly evaporate through Hawking radiation. Accretion disk and observable effects, there are none in the Harmon model. With real black holes that we have pictured, there are bright disks, jets, gravitational lensing, etc. There's all kinds of different effects. And our space telescopes are picking a lot of this stuff up. This isn't just kind of making stuff up. This is discovered. The quantum effects is it incorporates vacuum fluctuation arguments in black holes is described classically by the Hawking effect. And then the force behavior, Harmon uses GR to replace the strong force, but the strong force is irrelevant at that scale. So there's key differences. Now in scale, and he shows this scale in his documentary, Black Holes. Harmon's proton is 38 orders of magnitude smaller in mass than a stellar mass black hole, yet it's modeled as having comparative gravitational confinement. That's interesting. And this mechanism of confinement in classical physics is the strong force, and it binds the quarks in the proton, because protons are made of the smaller subatomic particles, the quarks, right? So in Haramein's model, this binding is explained gravitationally using general relativity. So there's a key difference. On evaporation and thermodynamics, Hawking radiation for black holes, Haramein's proton doesn't address the thermal properties. If it were truly a black hole, it would theoretically evaporate nearly instantly on the Planck timescales, and that's not observed at all. So there's problems there. Quantum consistency, the Hawking radiation rises from quantum field theory in curved space-time. Haramein blends the GR and quantum vacuum ideas, but the problem is there's not a consistent quantum gravity framework in his work. Not that we've seen so far. So the bottom line is the claim: proton shares some math with black holes. Mathematically, yes, if you assume the Schwarzschild radius is the proton a black hole, not by the standard GR. Real mass is far too small. So the proton's confinement force is gravitational? No, in mainstream physics, it's the strong nuclear force. Model offers numerical coincidences. Yes, it does, but some of these come from assumed inputs, so it makes it circular. Is it physically equivalent to a black hole? No, it lacks observational black hole features. Haramein's black hole does not have radiation. It does not have accretion disks. It does not have evaporation, etc., all of which are understood and known and seen. These effects are seen through various tools that we've been using for decades looking up at the skies. So now, in this instance, I said, okay, so now, on your considered expert opinion, if a proton is not a black hole, I'm still trying to defend Haramein because I think he's getting his eyes blackened here. So I'm trying to do my best to try to give it as good of a foot forward as I know how to, right? So if a proton is not a black hole, it appears to me Haramein's entire premise and thought of the unification of relativity and quantum falls apart. Am I fair to say that? Yes, you are absolutely fair to say that. And in fact, you put your finger on the central weakness of Haramein's entire theoretical framework. What is it? So let's unpack it. His core premise is that the gravitational behavior at the quantum scale, the proton especially, can be described using general relativity, the GR. So he's treating it as a kind of a Planck scale black hole. And that is what helps achieve a unification of general relativity and quantum theory. He does this through the geometry and the vacuum energy. He doesn't do it. So this is the foundation of his Schwarzschild proton paper, his holographic mass approach, his idea about the structure of space-time. It's a hollow fractographic universe, is what he says. So if the proton is not a black hole, as standard physics and empirical measurements demonstrate, then the entire mechanism he uses to unify the gravity and quantum mechanics, that collapses, since it depended entirely on modeling the proton as a gravitationally confined system. So why this is a critical flaw. So we know the comparisons haven't been very good, but now let's explore the why. And this is also extremely valuable for us. Haramein's assumption is proton is a black hole. If invalid, then the Schwarzschild formalism cannot apply and his model fails, right? So that's why it's critical to establish the proton is a black hole, and it appears to me like he's failed. So the strong nuclear force is gravitational in origin, is another claim, right? That's his assumption. But it's invalid, then the binding force must be described by quantum chromodynamics, not general relativity. We have proton confinement equals the curvature of space-time, but that curvature is negligible at this mass scale. So there's another problem. The proton radius is the same as the Schwarzschild radius, but they're off by 37 orders of magnitude. That is an absolutely unforgivably gigantic difference. And that means a major problem for the new model. And the Planck vacuum structure is what he says determines particle mass. It comes from the vacuum, the quantum vacuum, which is seething with energy, and it's got enormous density, 10 to the 98, he said, as I showed you earlier. And so from that, particles gain their mass. That's Haramein's determination. But if the proton is not a black hole, this falls apart without gravitational dominance. So the whole scaffolding of his unification is built on a foundation that standard physics, and this is key, every observation of the proton's actual mass and radius contradicts. Now, we have, and I'm going to, and this is important, I'm not trying to bore you with all these details. For me, this type of physics study and math study, we're not really doing the math, we're just showing you the rigor of the formulas and how to calculate stuff. You got to do a lot of memorizing and study first to work the math. But my key is this is necessary in order to arrive at a reasonable conclusion. You hear something and it turns you on. You hear something and you go, wow, yeah, I so love that teaching. That is so cool. And I myself have done that, right? So after the excitement kind of dies down, or you read a few books on a subject, etc., then you need to explore the nature of the evidence. Now, in physics, and especially with quantum physics, right? Everybody invokes quantum physics. In physics and relativity, etc., and chemistry and mathematics, etc., with quantum physics, the claims need to be verified with rigor. Look, it's just the nature of the beast, man. It has to comport to mathematics for whatever reason, and there's several books on this that are really good reads, by the way. Our world, our cosmos, etc., it just aligns so well with mathematics. It just does. It's astonishing how cool it is to be able to write down a bunch of little squiggles that are symbols and be able to describe a faraway planet and its very chemical makeup from 100 million light years away. It just staggers the mind. It's fabulous. But this is important. And that's what I'm trying to get to. So I like this kind of study. Every observation of the proton's actual mass and radius, we have used numerous different ways to find that out. So in physics, unification is pursued through quantum field theory in curved space-time. Now, Haramein does discuss this Yeah, right. So he's trying. It's also in loop quantum gravity. It's also being discussed through string theory, although Hofstadter, Sabine Hofstadter doesn't like string theory much. String theory is, yeah, it's tricky. There's a lot of arguments pro and con on string theory. It hasn't produced anything verifiably predictable itself either, so I'm not convinced by it. And this framework recognized that gravity is incredibly weak at the quantum scales. Haramein appears to me to be trying to overturn that. He's expressing gravity as being exquisitely strong enough to produce a black hole in every single proton. The mathematics doesn't work out. Based on the assumptions of the quantum vacuum, etc., it doesn't work out. Protons are governed by QCD, that is quantum chromodynamics, and Richard Feynman was huge on this. That's not general relativity. This is pretty well established at this point. And finally, a proton is roughly 10 to the 38 times too light to be a black hole. That's pretty important. So you're being completely fair, quite charitable. So who was responsible for finding the proton mass, etc., is kind of fun historical. Ernst Rutherford in 1917 identified the proton as a distinct particle. From the 1920s and 30s, Francis Aston, he used a mass spectrometer and he measured atomic masses. He discovered the mass of the hydrogen proton was slightly more than one atomic mass unit, AMU. And then from 1950s to the present, many physicists have been exploring this. And there has been, and see, this is what I say, they keep testing and studying and learning more about it. There's been increased precision through the cyclotrons, penning traps, QED corrections, etc. So it's not like science is sitting still. How was it determined? Through mass spectroscopy. They go through the, I'm not going to go through this, all the details. It measures the mass to charge ratios of ions. Here's how it works. I'm not going to go through the math or anything like that. Just know it's a rigorous situation. They're not just sitting there twiddling their thumbs when they're doing this. There's an energy mass equivalence with Einstein through the measurements, and we can back calculate the mass by rearranging E equals mc squared into m equals E over c squared. And that's the value of the math, is if you can manipulate it and then come up with very interesting ways of studying cyclotron and penning trap techniques from the 1950s. The charge moving in a magnetic field spins at a certain frequency. And that's what we're solving for, the mass. This is the formula. We take that M right there. It won't let me. We solve for the mass. Penning traps, they're using magnetic and electric fields. They trap a single proton. So see, there's various techniques. And today now, the most up-to-date mass of a proton, according to Kodata, this 2018, is 1.67 times 10 to the negative 27th kilograms. So when we look at the assumptions and correctants, modern proton mass calculations, these all bring in and include relativistic corrections, QED corrections, environmental corrections, cross checks with antiprotons. All of this is part of precision metrology. So, who? Ernest Rutherford, Francis Aston. How? Mass spectroscopy, measuring mass to charge ratio. Notice Haramein went mass to radius. He didn't talk about the charge. And when we use mass to charge, We can use particle motion in magnetic fields. That gives, we're pretty precise here, anyway. What is QED correction? And I just asked this off the top of my head so that we could get a little more detail. How did it help with finding and fine-tuning the proton mass? Excellent question. Touches the heart of modern precision. What is QED correction? Quantum electrodynamics. It describes how charged particles interact with electromagnetic fields, including each other and with the vacuum. And this is why I asked the question, because Haramein really does discuss in detail this quantum vacuum, the fluctuations in the quantum vacuum, the energy, the information density, is it accessible, etc. And that is really important. I'm not going to go through all the details on this. The Lamb shift is the energy levels in atoms are shifted due to QED effects, famously used to test quantum theories. These are all calculated using Feynman diagrams. So how does QED help in finding or refining the proton mass? You measure hydrogen atomic spectra. That is the electron transitions. When they jump levels, they either absorb a photon and it gives a dark light, or they emit a photon, which gives you a light a light band in the spectrum. And the precise energy levels depend on the proton mass, and then they go through it and all that. And the proton magnetic movement and the G factor, the QED loop corrections. There's a Penning trap cyclotron measurements. They describe the frequency. What they do is they isolate and trap a specific proton by itself. The corrections are parts per trillion, but necessary for the most accurate mass value. So this is not just mamby-pamby guessing here. Parts per trillions, they're getting down to nitty-gritty detail. That's impressive. So I'm just showing you that for the rigor. You can only determine the mass, the proton mass, if you account for quantum corrections from the quantum electrodynamics. So in parts per billion for mass errors. So now the vacuum energy connection. Haramein compares the calculated Schwarzschild's mass to vacuum energy inside the proton. This is one of his methods here. He uses Planck scale density arguments, concluding only 10 to the 29th or 10 to the 39th of that is needed for a proton to have its Schwarzschild mass. I asked the question, okay, so how does this help his argument, and why doesn't this work? Is his claim on the fullness of the vacuum energy accurate? How is that even calculated for real anyway? Okay. This is why I love ChatGPT. You can ask it all kinds of questions. You've zeroed in on one of the most critical and misunderstood parts of Haramein's argument, his use of vacuum energy. So this is good. This is what I was wanting to get to. How did he use vacuum energy? Well, it's often tied to the cosmological constant problem, to 0-point energy, and to Planck scale density. Let's walk through it. His argument, in essence, is he models the proton as a Schwarzschild black hole. His mass is way too big. He then calculates how much vacuum energy is inside the proton's volume. And he does this through Planck scale energy density of space. So it's enormously large. Remember, that was 10 to the 93rd grams per centimeter cubed. That's hugantic. That's gihugic. That's incredibly behemoth. So his idea is the Schwarzschild mass needed to make a proton black hole is only 10 to the negative 39th of that total vacuum energy. Therefore, the proton taps into a tiny fraction of the vacuum, and it is enough to make the proton a black hole. There is enough energy based on his calculation of an enormously large vacuum energy. He claims the proton is a black hole. Okay, so the vacuum is so full of energy that the strong force, the mass, the gravitational properties of the proton can be explained purely by vacuum structure. You don't have to go to quantum QCD. And this is what he calls a unification through vacuum coherence. Why does this seem so impressive? Well, I mean, he's using known Planck energy densities. That's valid. The math appears to be order of magnitude reasonable. He's pointing to a real issue, the vacuum energy problem. And even mainstream physics admits it's unsolved. So what this does is it gives the impression that the proton is not made of particles, but of organized energy patterns in the vacuum, a kind of a holographic resonance. Why this doesn't work scientifically? The vacuum energy problem is real, but Haramein misapplies it. So in quantum field theory, QFT, the vacuum has a 0-point energy because of the fluctuations, we all knew that, of all quantum fields. There's the calculation. This leads to the famous 120 orders of magnitudes discrepancy between QFT predictions and observed cosmological constant, the worst mismatch in physics. But, and here's the key, this energy in the quantum vacuum is not gravitationally accessible. It's not in a usable form unless general relativity couples with it or to it in a special way. But the way Haramein treats it, this raw energy density, is if you can get to it, if it were locally extractable. We don't have any known mechanisms so far on how to do this. This is what we would love to do because there is an infinite sea of this stuff out there in the cosmos, but we just don't have a way to do that yet. And here's the other issue that is, I can't argue with this. Why Haramein fails is just because vacuum energy exists in principle doesn't mean it manifests as usable or confining energy in a proton. Yeah, that makes sense. There is no mechanism known for how to get the energy out. We don't know how the proton taps into it. It's a numerical observation that Haramein is doing, not a physical derivation. That's numerology, not science. It contradicts established QCD, quantum chromodynamics, quarks and gluons, color confinement, asymptotic freedom, all extensively confirmed in particle collider experiments. Haramein's model doesn't produce Parton distribution functions. It doesn't produce deep inelastic scattering results. It doesn't produce proton-antiproton collision data. We do know protons have antiprotons, but there's no data that Haramein's model can produce. So he replaces all of this with a gravitational vacuum model. It has no QCD features. They say it's a huge red flag. So energy density does not equal actual energy use. So yeah, and we know the vacuum is dense, of course, with energy. But that's like saying there are trillions of calories stored in the Earth's atmosphere, so why am I hungry? See, unless there's a mechanism to convert that energy, it's not functionally available. And this is a central issue in zero-point energy research. So far as we have at this point, no experiment has ever demonstrated controlled extraction of vacuum energy. It'd be really cool if there was, but we don't have it. So then it shows how it's actually calculated in density. So it is enormous, but there's no known mechanism that says we can use it. Mathematically, he's correct, but it's physically meaningless. His model depends on flawed assumptions. It's not derivable. It's not predictive. It's not consistent with the data. So you are asking exactly the right question. Haramein's vacuum energy does sound deep, but it relies on non-physical use of QFT quantities. There's no clear mechanism, and it relies on numerical coincidences that don't produce real physics. So, and then I quoted another paper on the website Cosmic Core, and this is on Nassim Haramein's unification theory using the holographic principle. I wanted to at least touch bases with his use of the holograph, right? The holographic nature of the universe. And I wanted to at least touch on that. He uses oscillators, etc. So I use this information. I'm not going to take time to read all of it. He talks about quantum gravity and holographic mass. The spherical proton surface is akin to the event horizon around the black hole. He's still trying to utilize the properties of the proton as a black hole. And then the equations that he uses describes the ratio between the proton surface and the equatorial surface of Planck volume. It allows us to calculate the number of equatorial surfaces of Planck spheres that are on the surface of a proton, 10 to the 40th of them. So, and then equation 2 gives the number of Planck spheres contained in a proton, and there are 10 to the 60th number of Planck spheres in a proton, according to Haramein's model. So anyway, I just wanted to ask. So he says, as Haramein explains, we have derived the holographic gravitational mass of the proton, its Schwarzschild mass, from Planck units in geometry, without involving the Schwarzschild equation or the gravitational equations of Einstein's general relativity at any point. So gravity has been described as a ratio of mass to information to surface area, and has been accounted for completely in algebraic terms without involving space-time curvature, only through pixelation of the structure of the vacuum, the quantum vacuum itself. So for the first time, we have mathematical proof and a functioning description of quantum gravity. This is Haramein's claim. I wanted to touch upon this because the universe that you know is full of microscopic black holes and white holes. And here was my response to all of this. I would really like an evaluation of this method, the mathematics, the assumptions being made, the incorrect calculations, if there are any, the incorrect assumptions, if there are any, the analogies, etc. In other words, why is this not real? How come scientists won't accept this scientific work of Nassim? I am once again trying to establish that Nassim has a scientific theory that apparently undoes the standard particle model of reality of the universe, right? And it's showing that relativity can be used on the quantum level. He's using the physics, he's using the mathematics, he's trying to use logic and reason. He's wanting to get us to the truth of what is ground reality. Why is this not accepted? Because other people are using his material. That's why I quoted this article from the website Cosmic Core, because they too are showing how Haramein's work in this area appears to be really powerful, really good. Are we on the verge of an absolute breakthrough? So let's analyze the data, the mathematics, the assumptions, etc. Now, that's what I've been doing this whole time. I'm aware of that, but this took it in a different type of a nuance, and this is yet another area of Haramein's work that I wanted ChatGPT to be able to really analyze in good detail, and that's what got me so excited. The response here is truly breathtaking. All right, so I asked my question. Here's the answer. They're going to do it step by step. And I like this part of how they do, of how chat does this, and the why it fails the physics perspective. So his Planck spherical units. Now, this to me was one of the most interesting parts of his documentary. The graphics in his documentary are simply spectacular, and he is discussing the geometry, the breakdown of the geometry in the quantum vacuum. And my wife asked a very simple question that I had not thought of before, and when she watched this documentary with me, and she said, okay, wait. At this level, at the quantum vacuum level, there is nothing physical. So geometry, these shapes, how can they exist? And I think he's talking about the patterns of energy movement, etc., with the tetrahedrons and the toroidal effects of the energy and how the energy moves. Right? And so this is the Planck spherical units in a toroidal. It's a double toroidal. Watch his documentary. It's really interesting. The tetrahedron, and which is a pyramid, the tetrahedron. And then you take another tetrahedron and put it under it, and then you squish them down together, and they represent the Star of David. All of this is in an upper and a lower toroidal that are spinning in opposite directions. So the energy movement is going in and out of this toroid. Okay, very interesting. Want to just give you that quick background. So here's the problem with this. It is, he fills space with tiny spheres, voxels. These have a Planck radius. That is, each sphere is 1.6 times 10 to the negative 35 meter. And then he calls each of these a vacuum oscillator, which he does. Surface versus volume count, he counts 10 to the 40th of these Planck spherical units on a surface, and he counts 10 to the 60th Planck spherical units inside of the volume. And this is what gives him his holographic ratio. You take the number on the surface, divide it by the number in, and it comes out to be phi. And he says this is the proton mass. and it is purely geometrical. So he presents this as a derivation of quantum gravity through algebra. This is how he does it. Now, here's the problem. There is a lack of physical justification. Where do these spherical units come from? Again, the assumption is that they are fundamental quanta of space, but we have no evidence. There's nothing like it in quantum field theory. There's nothing like it in string theory. And it appears that all he did was make an assumption, and he made a series of derivations comparing to actual data. He provides no explanation for why Planck length spheres exist or why they oscillate. All right. There's a numerical coincidence does not equal prediction issue also. You adjust the PSU's counts to match the proton mass, but with free to choose ratios. Critics show factors of 2 or a quarter can appear arbitrarily. It's fixed post hoc via coefficients, yet there's no physical reasoning supporting them. There's no underlying dynamics. Here's another part of the problem with this. His method is purely static geometry. There's no mechanism explaining how these things interact. There's no mechanism for how proton stability is maintained. There is no mechanism for why these numbers apply across the scales. The true physics models require dynamical laws, not surface counts. So they're showing the differences, and it just appears to me like the current physics just simply can't find any justification for his proposals. And this one is a misuse of the holographic principle. So the holographic principle in physics relates black hole entropy and surface area through the D-branes or this ADS-CFT duality. I talked about that in my last video. Haramein's version treats the Planck spherical unit counts as identical to real quantum information. And this is an unjustified extrapolation. Now, later on, I ask about this exact point, and we'll get to it. I specifically point this out, and I say, wait a minute, hold on. So why real scientists reject it is there's no peer-reviewed and trusted journals. They always fall on that one. However, it's important to get it published in good journals. Apparently, Physical Science International is a known predatory journal. I have no idea what that means. I didn't check into it. So, I don't think the peer review, well, the peer review is important, but sometimes the gatekeepers can refuse stuff if it upsets their theories with actual evidence too. I don't know. So that's not as strong of an issue to me as it is to others. But this one, if it lacks dynamical validation, okay, so this is an important one. His model doesn't predict new phenomenon that it needs to do that. And the other one is it doesn't match particle collider data. Now, particle colliders have been happening for dozens and dozens of years. There are millions of data points there, right? And it has no link to quantum chromodynamics, no link at all, and yet it's supposed to be happening in the quantum world. That's a little iffy. And then, of course, he picks geometric ratios until they numerically match known constants. Proton mass, fine structure constant, and then he claims that proves reality. This is model tuning, not scientific derivation. All right. The foundational flaws, the Planck spherical units are not derived from any quantum gravity theory. The surface to volume counts don't imply interaction energies, stability, or dynamics, and it doesn't address the QFT vacuum puzzles, the renormalization, or gravitational coupling. But that's because it's a different type of theory. You don't need renormalization with his view, I don't think. So, and then there's a misstep here, the PSU diameter versus radius. It might work if you correct it in one instance, but then in another case, it breaks the electron side. This shows his framework is internally inconsistent. I have not pursued that as much as I want to, but PSUs are fundamental oscillators. It's unproven speculation. Proton mass derived purely from PSU geometry is numerology, not physics. Holographic principle applied is a misused. It lacks QFT-GR support. Proposed quantum gravity unification, there's no dynamics, no predictive value. Widely accepted by mainstream science, no, it's rejected as pseudoscience. They call it a geometric toy model. It reproduces numbers by design with no physical basis, predictive power, or consistency with established theories. It's not scientific, but it is numerological speculation. So, and this is my, I say this, claiming a tiny fraction of vacuum energy inside a proton could become mass ignores that quantum vacuum energy does not convert into mass in that way. That's what chat said. And I asked, so how does it work actually then? How is Haramein wrong here? Because he does say there's a fraction of vacuum energy inside a proton. And it's based on that vacuum energy that we get the mass of the proton, right? And they're saying, chat says, well, mass doesn't come through vacuum energy. So Haramein here is just wrong to get his proton mass that way. And it says, excellent. This gets right to the heart of the confusion around vacuum energy and its relation to mass. And this is one of the key points that needs clarified. We have to know what the quantum vacuum is, what its energy represents, and most importantly, and this is Haramein's entire basis for claiming we have access to all of this infinite sea of energy, why you just can't extract part of it to make mass. You can't do that. First, vacuum energy, like the electromagnetic field, the Higgs field, etc., has fluctuations. It's the baseline. Even in its lowest energy state, called the vacuum, there are still fluctuations. So empty space has energy. That's the point. And this is the physics of it. So each mode of a quantum field contributes a 0-point energy. And we hear a lot about this in our UFO stuff, right? Like a harmonic oscillator that never fully stops moving. There is always energy. However, and this is the idea that the vacuum is boiling with virtual particles, popping in and out of existence. Okay, so how large is this energy? You get a colossal energy density. Here's how you do it with this equation. This is the Planck scale energy density. It's approximately 10 to the 113th joules per meter cube. That is pretty colossal. Here's the key issue. It is not physically accessible in the way Haramein suggests. And this is the key issue. So why can't we just use a fraction of that energy? Because it's not like gas in a gas tank. It's not a reservoir of usable energy. That's the problem. We wish it was, but it's not. It's a mathematical offset in the baseline energy of quantum fields. That's what it is. Only differences in energy matter. General relativity and quantum field theory both treat energy differences, not absolute energy, as physically meaningful. So unless there's a change in vacuum energy, a phase transition, say, it doesn't do anything observable, right? That's why the Casimir effect, which does show measurable vacuum energy differences, works. It's a differential effect. You can't localize it to make mass. This might be very critical too, because there are specific mechanisms for mass. And vacuum energy does not clump or localize into massive particles unless there's a field excitation, which is a particle, or there is a spontaneous symmetry breaking, like the Higgs, or there is a vacuum instability, like false vacuum decay. All of this is just skipped, and Haramein says there's a ton of energy in the vacuum. So if a proton just uses 1 in 10 to the 39th of that, we get the proton's mass. But without a mechanism, this is like saying there's enough oxygen in the room to make a fire, so I must be on fire now. Interesting analogy. That kind of helped me understand where the problem in Haramein's claim is. So it's just, how does mass actually arise? The system with the electron is the Higgs field. The electron gets mass by coupling to the Higgs field. More coupling, more mass. The proton is QCD confinement energy. Quarks only account for about 1% of the proton's mass. The rest is binding energy from the gluon field. That is holding the quarks together. Okay, and the macroscopic objects, the sum of particles massing and binding energy, the mass of things like atoms or planets comes from the particles and the fields binding them. And dark energy and vacuum energy, the cosmological constant, observed only through the expansion of space, not via direct mass creation. Dark energy is very, very questionable with so many physicists. This is why Haramein's claim fails. A proton mass can come from tapping the vacuum. No. Vacuum energy is not extractable like that. The vacuum is full of energy. This is true, but only differences are physically meaningful. We can convert a tiny fraction into real mass, not without a mechanism like Higgs coupling or field excitation. Therefore, the proton is a black hole. No, It assumes energy is the same as usable mass, which it is not. So, Haramein treats vacuum energy like a bank account from which we can withdraw mass. But in reality, it's more like the 0 point on a thermometer. It's always there, but it doesn't mean the system is hot unless it changes. So to truly create mass from vacuum energy, you need to excite the field, trigger symmetry breaking, or change the vacuum state, none of which is addressed in Haramein's model. So here is what else they said. Haramein's version treats the Planck spherical unit counts as identical to real quantum information and unjustified extrapolation. Here's what I asked it. I said, okay, wait. So PSU counts aren't actual quantum information. Can you explain why? How come it's an unjustified extrapolation if it's involving real information that is entangled through the universe with other particles? If everything is connected through entanglement, it seems the entire universe is informed from everywhere all the time, and we can tap into that. Is that unjustified? See, I'm trying to bring in more of Haramein's ideas that this physics he proposes is leading to. And so I'm just trying to get as much clarification as I can from the scientific physics point of view. And ChatGPT really did something interesting here. This is a beautiful, deep, and nuanced question. You're touching on the edges of quantum gravity, the philosophy of information, and metaphysics. Let's work through it carefully and respectfully. Okay, so I get the impression that chat is getting the impression that I'm getting testy. So are the Planck spherical unit counts actual quantum information? No, not by any standard in quantum physics. Here's why. What counts as quantum information? In mainstream quantum information theory, information refers to qubits, the smallest units of information carried, and these are like the spin states of electrons. It involves entanglement, which is correlation between the states of two systems that cannot be described independently. It is von Neumann entropy, which measures the information content in a quantum state. This is well defined mathematically using Hilbert spaces, density matrices, and entanglement entropy. In black hole thermodynamics, now this is in black hole thermodynamics, the holographic principle says the maximum energy or the maximum entropy information in a region of space is proportional to its surface area, not its volume. And this is the famous Bekenstein-Hawking formula, which I talked about in my previous video. So in this context, information is not the count of little spheres. It's the number of distinguishable quantum states on a horizon. That is very interesting. That is very interesting refutation. Haramein counts the spheres. That's not what's supposed to be counted. Well, then what are Haramein's Planck spherical units? He imagines that space is filled with spheres of Planck length in diameter, like voxels of space. And then he counts how to fit them on the surface, how many fit in the proton. Then he divides the two numbers and he multiplies by the Planck mass to get the proton mass. But this process doesn't represent actual quantum information because these spheres aren't quantum systems. They have no quantum states. They aren't physically entangled. There's no demonstrated or proposed interaction between PSUs and real particles. And they aren't excitations of any field, where real particles are excitations of quantum fields. For instance, the electron is an excitation of the Dirac field. So his PSUs are geometrical units, but they don't carry entropy or state information in the quantum sense. That is very critical. That's interesting. Why is it an unjustified extrapolation? Because he takes a geometric counting exercise, how many balls fit in a box, and he asserts that this is quantum information, that information equals gravitational mass. Therefore, gravity is a function of vacuum structure through information geometry. This is important. He says it is quantum information. Information equals gravitational mass, and gravitation is a function of vacuum structure through the information geometry. But he never derives this from quantum field theory. He never shows that Planck spherical units counts correlate with entropy states. He never defines quantum coherence or entanglement for these spheres. So it's not a derivation. It's a philosophical metaphor wrapped in numerology. Now, what about universal entanglement? This is a beautiful and intriguing idea, often echoed in mysticism, consciousness studies, and some speculative physics. Everything is entangled with everything, so the universe is informed everywhere, but there is a key distinction. All particles were entangled from the Big Bang is what the claim is, but that's possible. But most of that entanglement is decohered, that is, lost. Everything is entangled now. No. Decoherence destroys observable entanglement over time and distance. We can tap into the vacuum's entanglement structure to get information or energy. No. Because no known mechanism in QFT or GR allows this. So in quantum field theory and quantum computing, entanglement is fragile. Once two particles interact with the environment, decoherence, they're no longer entangled in a usable way. So entanglement is not permanent. So Haramein's cosmic entanglement idea has philosophical and poetic beauty, but no scientific mechanism to back it up. So, no, they're not quantum states. They don't carry entropy, and they're not defined. No, there's no derivation. There's no interaction model, and there's no physical laws that bridge the gap. The idea of universal entanglement and is it scientifically valid? No, it's poetic and suggestive, but entanglement decays. That's it. That's critical. Entanglement actually does decay, and no evidence is available that we can tap it. So is his model scientific? Well, it uses scientific language, but it lacks physical derivations, predictive power, or testability, and that's important. So they are fascinating, his ideas. He's been tapping into deep intuitions about the unity of the cosmos. But physics demands more than vision. It has to have mathematical structure, and it does, experimental validation, and logical coherence. Without that, it's philosophy, not physics. Ouch to philosophy. So Here's another point that I brought up because I wanted to be thorough. It said that he provides no explanation for why Planck length spheres exist or why they oscillate. But I said in his documentary Black Holes he did, it's a double toroidal oscillator with information going into and out of it on the other end. He also proposes they exist due to the geometry of space-time in the form of tetrahedrons within spheres. Spin creates coherence across all particles in the universe, doesn't it? Isn't that what he is indicating is also a useful, if not necessary, way information and knowledge can be found universally in everyone because of the entanglement of all protons, both in us and throughout the universe? So here again, when they say he provides no explanation for why Planck length spheres exist or why they oscillate, I'm trying to defend him in his documentary. I want to just make triple sure we understand and not misstate what Haramein is saying, right? I want to make sure I get this right and I'm using multiple sources. I'm trying to give him the maximum benefit of the doubt that I can. This is a powerful and thoughtful interpretation, and you're right that Haramein is building a metaphysical framework that attempts to bridge geometry, quantum mechanics, gravity, consciousness, and universal unity. You're also right that in Black Hole and related presentations, he discusses the double toroidal geometries as the basis for oscillation, the tetrahedral packing in space as the root of vacuum structure, spin as a universal coherence mechanism, and entanglement as a universal informational substrate. So this is what Haramein is doing. So let's look at what this vision represents. Let's see what it does and doesn't accomplish. That's important scientifically. And why mainstream science doesn't yet accept it, not as a dismissal, but as a matter of standards. So let's look at Haramein's vision expanded. The Planck spherical units as oscillators. It's not static, it's a toroidal oscillator. A black hole, white hole structure. These process information. Energy flows inward through the black hole and outward through the white hole. Their structure is based on a tetrahedral or flower of life geometry. This implies that space itself has crystalline coherence. Here's the critique. This vision is rich with metaphor, but it lacks a dynamical equation describing the oscillation. It lacks a field or a Hamiltonian governing energy transfer. It lacks any experimental evidence that such toroidal Planck units exist. So on spin as universal coherence, he points out that everything spins from galaxies to protons. He interprets this as a sign of deep geometric coherence. Spin is what locks the universe together. So in this view, spin mediates entanglement, and the rotation of the vacuum is the source of information flow. So in physics, spin is an intrinsic quantum number. No actual physical spinning is occurring. Spin is not directly responsible for entanglement or non-locality. Spin is not the cause of universal coherence, though it plays a key role in quantum behavior. So the idea that spin connects everything is philosophically compelling, but it's not rigorously defined in terms of wave functions or symmetries that describe real physical systems. So on this idea of all protons are entangled, Haramein speculates that since all protons were once in close proximity at the Big Bang, that they are still entangled, and that this entanglement is informational and usable. He uses this to support his idea that everyone is connected and that consciousness can access universal information through the vacuum. However, global entanglement is possible in principle, but not useful unless it's coherent. Decoherence happens extremely rapidly in open systems, and entanglement is not eternal. And it's not functionally usable across cosmological distances either. So this is a metaphysical extension of physics. That it is. But it's not backed by experimentally demonstrated entanglement or quantum channel models. And that's the deal breaker. That's why science doesn't accept the framework, not out of dismissal, but because scientific acceptance requires predictive equations. It requires testability. For instance, there's no experiment proposed to confirm toroidal Planck units in Haramein's model, right? It needs quantifiable dynamics. It needs consistency with QFT and GR. It conflicts with both. In other words, the proton is not a black hole, as we have thoroughly seen. It does need peer-reviewed validation. So to be fair, speculative frameworks are often ahead of their time, but until they are quantified and testable and reproducible, they are considered philosophical constructs, not scientific theories. So where does that leave us? Well, Haramein is offering a metaphysical cosmology. Now, there's nothing wrong with that. It's rooted in visual geometry, ancient symbolism, and deep intuitions of interconnectedness. And this does inspire people. It does. And that has value. It does. But inspiration does not equal demonstration. So without the mathematical rigor and the empirical support, physics cannot accept it as an alternative to quantum field theory or to general relativity. Now, it is important to say that it's perfectly valid to say, I find Haramein's model spiritually meaningful or intuitively compelling. That is valid. But it's not valid to say this has proven quantum gravity and unified physics, because that requires rigorous, testable science. So, the final thought, you're right to sense that spin and structure and connection may point to something deep and profound. And Haramein's model resonates because it speaks to a need for wholeness in understanding reality. But physics only accepts such claims when they can be mathematically derived, empirically validated, and predictively falsifiable. So until then, Haramein's work lives in a philosophic or an esoteric domain, not the scientific one. And that's fair. That's fair. And then I kept going. Oh, no. I copied that twice. Okay, so no, here we go. No, I want to get to this. What's inspiring and intuitively compelling? There is a genuine poetic and philosophical power in this line of thinking. It aligns with the holographic principle as developed by 't Hooft and Susskind and later elaborated by Hawking and Maldacena. The idea that information is fundamental and that surface area encodes volume, the intuitive notion of interconnectedness, that the universe is in some sense entangled and unified at the deepest level, and you have the ancient mystical idea from Vedanta to Kabbalah to Platonic philosophy that the part contains the whole. These are not silly or unscientific intuitions. They are profound insights that many great thinkers have wrestled with. But intuition must be distinguished from derivation. And that's actually the bottom line. I think I've gone on long enough. Matching numbers is not derivation. Coincidence does not equal causation, right? Many wormholes are assumed, they're not derived. There's no mechanism in quantum gravity or general theory showing that each Planck sphere contains a wormhole, or that protons are actually connected by wormholes, or that mass arises from this network. So, very interesting. You cannot just distribute mass over the universe. The step where he divides the Schwarzschild proton mass, 10 to the 14th grams, by the number of protons in the universe, then multiplies by surface PSU count. Notice what he left out. To get 1.67 times 10 to the negative 24th grams is a mathematical trick, not a physical law. He tunes the numbers to land on a known value, such as proton mass. And then he says the match proves the theory, but there is no mechanism. There's the downside. There's no mechanism for how the mass actually flows between the protons through the wormholes to average out that way. See, that's like saying divide all the money in the world equally and you'll get the average income. Therefore, the economy is holographic. That's not how it works. Entanglement does not equal usable connection. It's a statistical correlation of states. You cannot signal or move mass through entanglement. Most entanglement decays. That's called decoherence. And so while it's metaphorically profound to say all protons are entangled, it doesn't follow that they exchange energy through wormholes or that the proton's mass arises from the entire universe. That's speculative philosophy, not falsifiable science. So then what is the holographic principle? The maximum information of a region of space is proportional to its boundary area. None of this implies that every Planck unit is a wormhole or that the proton's mass arises from universal averaging. So, nope. So is the universe holographic? Maybe. Hawking, Susskind, and Maldacena all seriously consider it in very specific mathematically structured context. Well, does this imply that we're all connected? Again, a powerful philosophical idea. It's echoed in both physics through entanglement or entropy bounds and spirituality. Is Haramein's version valid science? Not yet. It's a metaphysical narrative using scientific language, but without the derivations or the mechanisms or the predictions. Well, does that mean it's worthless? No, absolutely not. It stimulates thinking. It imagines bold possibilities. It bridges gaps between science and meaning, but it must not be confused with established physics until it meets scientific rigor. So that is what is so important. Yeah. The circular reasoning, the proton is a black hole because it has a Schwarzschild radius. And we know it has a Schwarzschild radius because it's a black hole is entirely invalidating to pretty much everything Haramein says. So that's basically my critical response to Haramein's exquisitely interesting and brilliant theory, but it's not scientific. So I wanted to give both sides of this. So there you have it. When I find more information that I can share with you, I'll be happy to do so. In the meantime, hit the like and subscribe. Share this video with as many people as you want or you can so that they can understand the difference between how to analyze something critically and just believing it because someone throws a math equation at you or makes it sound convincing. And I will catch up to you just as soon as I can. You guys have a great day.